We have a 15-foot ladder that is leaning against the building. The bottom of the ladder is on level ground and begins to move away from the building at a constant rate of half a foot per second. So over here is going to be the ladder. Think of this as the hypotenuse of this right triangle, and the building is going to be over here. So we'll call the bottom of the triangle X, the height Y, and we're given that the bottom of the ladder, or the bottom of the ladder is on level ground and begins to move away from the building at a constant rate of half a foot per second. So that's going to be dx over dt equals 1/2. It's going to be positive because this distance, this distance x is increasing. So as the ladder moves away from the building, this base here gets bigger and bigger. So now we want to find the rate in feet per second at which the top of the ladder is sliding down the building when the foot of the ladder is 9 feet from the base of the building. Basically, you want to find dy over dt when the base here is 9 feet. Okay, so first we want to come up with an equation, and the ladder, by the way, is 15 feet. So Pythagorean theorem says x squared plus y squared equals 15 squared, which is 225. Now we're going to take the derivative of everything to get 2x dx over dt, 2y dy dt equals 0. Now notice that, okay, you may be asking, why didn't you just do set the ladder equal to, let's say, h? Well, the reason I didn't do that is because the height of the ladder stays the same. So you don't want to put it as a variable. It's always going to be constant. So when I take the derivative of this, it should be 0. So the length is constant, which means leave it as a constant. Constant being 15 here. Okay. So now I can make an expression. I can solve for dy over dt. First I can eliminate the 2's, and then I'll just move the x dx over dt to the right. And so I'm going to divide both sides by y and get negative x over y dx over dt. Now, we know that the hypotenuse is always going to be 15, right? The height of the ladder does not change. Now, this looks like a 3, 4, 5 triangle. The hypotenuse being 15, base being 9. Think about it. 3 times 3 is 9. 5 times 3 is 15. That means 4 times 3 has to be 12. So this height is 12. X we said is the base, that's 9. The height we solved for is 12. Dx over dt was given to us as 1/2. Now, 9 over 12, that's the same thing as negative 3 over 4. So we're multiplying that by 1/2 to get negative 3 over 8. So dy over dt is going to be negative 3 over 8. And we should include units here. So the ladder is 15 feet, and we're talking about per second. So this is feet per second. Now I want to find the rate of change in square feet per second of the area of the triangle formed by the ladder, the building, and the ground when the foot of the ladder is 9 feet from the base, or from the building. Okay. Now, if we said this is x, this is y, this is 15, the area is 1/2 times base times height. So we want to see the rate of change of the area, so that's dA over dt, which we have to use a product rule here. So the derivative of x is dx over dt times y, plus the derivative of y is dy over dt. We said that the base of the ladder is 9 feet. So that's similar to up here. That means y has to be 12. So dx over dt was given to us as 1/2 initially, if we go all the way up here. And we just solve for dy over dt to be -3/8. So y is 12, x is 9, dy over dt. Under the same circumstances, right? We had this right triangle, 9, 12, 15. dy over dt was -3/8. So I can use that here because we have the same triangle. And so now at this point I just simplify. So 1/2 times 1/2 times 12, that's basically 12/4, which is 3. And then we have 9 times 3 is 27. 2 times 8 is 16. So think of this as like 48 over 16 minus 27 over 16. That's going to be 21 over 16, and that's going to be feet squared, because it's area, over seconds. And that's my answer.